The set of imaginary numbers is a set of all numbers written in the form a plus bi. These are definitions that you did last night. A and B are real numbers, and B is not equal to 0. A pure imaginary number is a number of the form bi, where B is not equal to 0. So they're asking, write the imaginary number I in the form a plus bi. What are the values of a and b? So we just needed to equal I. That's it. We need to equal I. So what could I add to it that it still just equals I? What number can you add to stuff and it doesn't change it? 0. So I'm going to say 0 plus. Now what am I going to multiply it by so it doesn't change it? 1i. Value of a is 0. The value of b is 1. So what's an example of a pure imaginary number? Just a number that doesn't have a real part to it. I gave you some examples earlier when we were going over our definitions. We had some examples in our homework. We had some examples on your Go work. What was the answer to this one? That's a pure imaginary number. 7i. There's nothing real about it. It's 7i. Okay? This one? Yeah. And this one? Yeah. So, was this a pure imaginary number? Why not? It had that real part to it. Yeah. Okay. So those are examples of pure imaginary numbers. Can a number be both real and imaginary? Can it be? It cannot be both real and imaginary. In order to be both real and imaginary, either A would have to be 0. Well, if A is 0, then it's just imaginary. Or B would have to be 0. And if B is 0, then it's just real. So it can't be both. One of these would have to be 0. And if it's 0, then it's not there. There's nothing there. Alright, you have that? You have an understanding of that. You get it? Sort of? Okay, someone asked earlier, not in this class, in a different class, who actually uses these? Imaginary numbers have applications in real life. A lot of you in here will not have a job that uses imaginary numbers. You just won't. If you go into engineering, you very well could use them quite often. They are used in electromagnetism, fluid dynamics, quantum mechanics. There are applications where in fluid dynamics, when you're talking about water flow through a certain pipe or something like that, that has applications with imaginary numbers. Now, if you grow up and become a doctor or a lawyer, that's not going to be part of your job. If you grow up and you become a civil engineer or you design buildings, that's going to be part of your job. So not every job uses them. Okay? But we need to learn them because in the 10th grade, you're really not sure what your job's going to be. So we don't want to limit you yet. You need to learn these. Okay? Alright, let's look at the next part. Alright, so we have real numbers and we have imaginary numbers. Well, the set of complex numbers is a real number and imaginary number put together. You're adding them together or you're subtracting them. The real part is the A, the imaginary part is the B. Okay? Is this a complex number? No? Some people said yes, some people said no. No? Can I write it like this? Does it have a real part and an imaginary part? So it's a complex number. Is this a complex number? Is it a complex number? Yeah, it's a complex number. Because I can write it 3 plus 0 times I. Boy. So, yeah, it's a complex number. How about this one? Is that a complex number? Yeah? Be catching on to what I'm doing here. That's a complex number. Oh, here's a good one. Is that a complex number? Yes. It has a real part, and it has an imaginary part right there in front of you. So basically all of these are what? They're all complex numbers. They're all complex numbers. So look at number 5. I'm going to leave this up here so we can look at this while we're talking about number 5. But look at number 5. What is the difference between a complex number and an imaginary number? Complex has a real part. Alright. Complex has a real part. If it's imaginary, is it also complex? Yeah. If it's real, is it complex? Yeah. Because I can use 0 there. Only some numbers are imaginary. All numbers are complex. That's going to lead us to number 7. Let's work on number 7. Oh, no, number 6. We'll do 7 in a minute. Alright, create a diagram to show the relationship between each set of numbers shown. Complex, imaginary, integers, irrational, natural, rational, real, and whole. What's the biggest heading that all of these fit under? Complex. All of these are complex numbers. Now, if they're complex numbers, what 2 parts do they have? Real and imaginary. Can we split real numbers into two groups? What are the two groups of real numbers? Even bigger. Rational and irrational. Exactly. Real numbers can either be rational or irrational. Now remember way back we talked about sets of numbers, like 100 years ago. What's the next smallest set of numbers after rational? Whole numbers? Whole numbers are 0, 1, 2, 3, 4, 5. There's a set on here that's left that's bigger than that. Integers. Because integers are whole numbers and they're opposite. And then after integers, what's next? I kind of just told you in the definition. Whole numbers. And then the smallest set of numbers, natural. Some people call these counting numbers because when you start to count, you start with 1, 1, 2, 3, 4, 5, and natural numbers start with 1, 1, 2, 3, 4, 5, and up. I want you to do number 7, the always, sometimes, never. I want you to do that for homework. Always, sometimes, never on number 7. I want you to do that for homework. Finish getting your chart filled in. And then do your always, sometimes, never on number 7 for homework.